Hello everyone, I'm Sebastian Y and this is Managerial Economics. Over the next few videos we are going to do a quick review of those fundamentals of microeconomics, supply and demand, as well as talk about elasticity. These concepts are likely to be review for a lot of you, but it may also have been a little while since you've had a principles course, so we're going to try to knock that rust off here, as well as start to slowly pull in some calculus concepts that we're going to be using for the rest of the course and that you might not have seen applied to these ideas. In this first video, we are going to talk about demand. Before we get into it, I want to define the term ceteris paribus. It's a Latin phrase that means all else equal. We're going to be looking at some very complex economic systems. The idea of ceteris paribus is to examine what might happen to that whole system if one variable changes while holding everything else constant. We're going to be coming back to this concept over and over as we go through this course. The law of demand states that as price goes up, the quantity demanded falls, and vice versa. The intuition behind this is that some people are willing to buy at higher prices, some people are willing to buy at lower prices, and so the lower the price goes, the more people are going to get on board to buying the good. The idea of diminishing marginal benefit is also a factor that we will talk about later on. Mathematically, we are going to be using what we call the demand function to represent the demand for a good. Let's consider an example, demand function for good x. Here, x could be anything you want. When we write a mathematical function, the variables inside the parentheses here are the independent variables that go into that function. Our example will be 200 minus 2px. So on the left we have quantity demanded, on the right we have the price. We see there is a negative relationship here according to the law of demand. We're going to be doing a lot of work with demand functions throughout this course, so it's a good idea to get used to working with them and get used to graphing them. The easiest way to graph a demand function is to draw the axis, always label price on the vertical axis, quantity on the horizontal. Since the slope of a demand function is negative, it's going to be downward sloping. The easiest way to graph a demand function is to figure out the intercepts. For the quantity intercept, we need to know what would the quantity be if the price were 0. We can do that by plugging in 0 in for px, so we get 200 minus 2 times 0, which is 200. So I'm going to mark that out on our graph. To figure out the price intercept, we're just going to plug in 0 for the quantity. We want to know how high does the price have to get in order to drop the quantity demanded all the way down to 0. So we're going to put in 0 equals 200 minus 2px, add the 2px to both sides, and then divide both sides by 2. So we get px equals 100. So that's going to tell me my price axis intercept is 100. For consistency, I'm always going to try to use a blue line for our demand curve, so we're just going to link up those 2 points. That's going to be our demand curve. To use the demand function, we can just plug in any price we want to figure out what the quantity demanded might be. For example, let's say we wanted to know what would happen if the price were 50. We could just put in 200 minus 2 times 50. 2 times 50 is 100, so we get 200 minus 100, which is 100. We can put that on the graph. 50 is halfway here, 100 is halfway here, and the point we found is right there on our demand curve. So far, we've been considering only the relationship between price and quantity demanded. It's a two-dimensional situation. But in reality, price is not the only thing that affects a person's decision to buy something. There's all kinds of other things going on. Like I said, economic systems are complex. They have a lot of variables in them. We're just thinking about price ceteris paribus right now. When we change the price, say to 70, then that's going to change our quantity demanded as we move along the curve. When another variable changes, that's going to shift the entire demand curve. An increase in demand is a shift to the right. That's going to increase the quantity demanded at every given price. So here, at a price of 50, we've got a much larger quantity demanded than before. On the other hand, a shift to the left represents a decrease in demand. Less quantity is going to be demanded at every price. Let's talk about some factors that can shift our demand curve. Any given demand curve could be affected by hundreds or even thousands of things, so we're just going to give a few examples. One of the most important factors is the income of consumers. For a normal good, an income increase leads to a demand increase, that is a shift to the right. And likewise, for a normal good, an income decrease would shift the demand curve to the left. For an inferior good, it's the opposite. An income increase leads to a decrease or a shift to the left of demand, and an income decrease leads to a shift to the right. While normal and inferior are common words in English, in econ they have these specific definitions. Whether a particular good is normal or inferior depends on the specific person and their current level of income. For example, one person might view bus tickets as an inferior good, while economy class plane tickets are a normal good, but a person with a very high income might view the economy class tickets as an inferior good and first class tickets as a normal good. Another important factor is the price of related goods. For substitutes, a price increase in one good increases the demand of the other, that is, shifts it to the right. Generally speaking, substitutes are goods that serve a similar purpose to each other, and so if one good gets more expensive, people switch over to the other. For example, Coke and Pepsi. For complements, it goes the other way. A price increase in one good increases the demand for the other or shifts it to the right. Generally, complement goods are those that are used together and make each other more valuable. For example, peanut butter and jelly. If the price of peanut butter were to go up, you're going to buy less peanut butter, according to the law of demand, and consequently also less jelly. One of the less quantifiable factors here is a change in taste. That's just how much do consumers like a particular good. For example, the taste for cigarettes has decreased over the years as the health risks have become more known, slowly shifting the demand curve to the left. But firms can also get involved here by using advertising to get people more aware of their product and to persuade them to buy it. Final consideration is a change in the population. The simplest way a population can change is just an increase in the size of the population or a decrease due to something like immigration. But also, changes in the composition of the population can change demand. A product might have a particular appeal to one segment of the population, and if the proportion of that segment within the overall population changes, that's going to shift demand. With all of these factors in mind, we need to come up with a way to incorporate them all into our demand calculations. We do that by building a more complex demand function than we've had before. As an example, let's think about the demand for beer. I'll put B here for beer, and say that the quantity demanded of beer depends on the price of beer, consumers' income. We often use the letter M to stand for income, the amount of advertising the beer companies do, and the price of a related good, wine. So we'll use PW for the price of wine. This function could be extremely complex, or it might be pretty simple. Throughout this course, we are going to use a linear functional form for the demand function. That means it's going to look something like this. Alpha naught plus alpha 1 times PB plus alpha 2 times M plus alpha 3 times A plus alpha 4 times PW. These alphas here, these are just numbers. Could be positive numbers, could be negative numbers. It just depends on the relationship between the variable that's next to that coefficient and the quantity demanded. For example, due to the law of demand, we would expect alpha 1 to be a negative number. Advertising tends to increase the demand, so alpha 3 is probably a positive number. For alpha 2, it depends on whether we think beer is a normal or inferior good, and for alpha 4, it depends on what's the relationship between wine and beer. Since they're substitutes, it's probably going to be positive. For now, I'm just going to give you values for these coefficients, but in practice, what we would do in the field is to use regressions to estimate these numbers, and we will get there later in the course. For now, we'll assume that the demand function is 500 minus 10 PB plus 4m plus 5a plus 2pw. Unfortunately, we are unable to draw a graph of this because we now have 4 variables on the right-hand side, meaning that we would have to draw this in 5-dimensional space. I don't know about you, but I can't really imagine that. We're going to have to boil this down into a 2-dimensional graph. What goes on our graph? Price and quantity. So we are going to need to specify values for all of the rest of the variables. Let's assume that M, the income, is 65, level of advertising is 8, and the price of wine is 50. This now boils things down to 500 minus 10 PB. We have not specified a price for beer yet, plus 4 times 65, plus 5 times 8, plus 2 times 50. Adding those all up and collecting terms, what we end up with is 900 minus 10 PB. We can draw a graph of that, just like we did before. Quantity and price, label that up. What are the intercepts? The quantity intercept's 900. Just put 0 in for PB. Now, if we put 0 in for QB, we would see that we need a price of 90 to get this down to 0. 900 minus 10 times 90 is going to be 0. Get 90 up here. Connect those up to get our demand curve. Label it with a D. We can now use our demand function up at the top of the screen here to do a demand shift. Let's suppose that income increases from 65 to 90. We can now recalculate the demand function. QBD equals 500 minus 10 PB plus 4 times 90, and then everything else is the same. 5 times 8 plus 2 times 50. Collect all those terms together, and what we end up with is 1000 minus 10 PB. Putting this on the graph, we now have a quantity intercept of 1000. 1000 divided by 10 is 100, so we now have a price intercept of 100, and we've now gotten a demand shift to the right. So that tells us that beer is a normal good. We have a positive relationship between income and demand. Our final topic for demand for the moment is consumer surplus. Consumer surplus is the willingness to pay minus the price that a consumer actually paid for a good. To see this on a graph, let's just arbitrarily pick a price of 60. I draw this across and we can get what the quantity demanded is. We'll use the original demand curve here. If the price is 60, our quantity demanded, just plug that 60 right in, and what we get is 300. Every point along our demand curve is somebody's willingness to pay. And so if consumer surplus is the distance between that willingness to pay and the price, that's going to be somebody's consumer surplus. This is going to be someone else's. This is going to be someone else's, and so on. And what we end up with is an area below the demand curve and above the price. That's going to be our consumer surplus. Mathematically, this is an integral. Luckily, though, we are going to be dealing exclusively with linear demand functions, and so the integral is actually a triangle. We can use the area of a triangle to calculate what the consumer surplus is. Remember that the area of a triangle is base times height divided by 2. And so we can apply that here. The base of our triangle is this distance, which is 300. The height of the triangle is this distance. That's going to be 90 minus 60, which is 30. We divide that whole thing by 2. What we get is 4,500. If we change the price down to, say, 40, we can recalculate the consumer surplus. The quantity demanded here is 500. And we can get a consumer surplus of 500 times 90 minus 40, which is 50. Divide that by 2, we get 12,500. 500. I use a green triangle to do that new consumer surplus right here. So as price goes down, the base and the height of the triangle increase, and our consumer surplus increases. That's the basics of demand. Next time, we'll talk about supply.